Welcome back. Don't worry, it's over. You won't have to do this again. Now, why did I want you to step manually through this and essentially be the computer, apart from keeping you occupied for the better part of an hour? Because this is a really, really useful skill when it comes to programming, being able to be the computer and manually step through your program, for example, on a piece of paper. And this is really, really helpful when it comes to debugging, because chances are you're going to implement a program and it won't do exactly what you want it to do, at least not in every cases, and at least not in every case, and at least not to start with. Now, I tell my students to do this all the time. I don't think that anybody ever really does it, and then they come to me and they're like, well, hey, I've tried to implement this, my program isn't working, why is it not working? Well, I don't really know. I kind of, have to step through it myself to see what's happening. So that's why I wanted you to practice this. Because if you know what to expect, it makes it much easier to debug a program that isn't doing what it's supposed to do, where you can essentially, in your program, put in debug statements, print statements, something like this, so you can figure out exactly what's happening, and then you can compare that to your manual run on your piece of paper and see that, oh, hang on, okay, it's getting a 3 here and it was supposed to get a 4. Why does that happen? Oh yeah, okay, I found the bug. So I just wanted you to do this, not because you will be doing this all the time, hopefully not, unless your programs are really, really buggy, but just to get into kind of the spirit of doing this and not to shy away from it. We're like, oh my god, this is really tedious. I just want the computer to do it for me, because again, chances are when you're implementing a program yourself, the computer isn't going to do exactly what you want it to do, and then you have to figure out how, right? And this is a great way of doing it. Great, if somewhat tedious, but at least you only really need to do that once, right? Once you have one worked example that will help you with at least the basic debugging for your program. At least, of course, there might be specific cases where you still need to kind of come back and then do that specific case because that's what's broken and you have done a different case before. But that can also really be useful if you're still trying to develop the actual algorithm for solving the problem that you're interested in. Because in particular, exploring edge cases manually can get you to really think about what is it actually that I want my program to do. You might not even be entirely aware of this. Well, what in this particular edge case do I want to happen? Like, for example, I want to say sort a list of numbers. And there's a particular edge case where all the numbers in the list are the same. What do I want to happen in that case? Does it just return the list unchanged? Does it kind of move some elements around and I'm not even aware of what's happening there? Probably makes most sense to return it unchanged, but is that actually what your algorithm is going to do? Great way to check this is run through it manually. Of course, you can only do this for relatively small examples, as you have just seen, but that not only gives you a better understanding of what your program should be doing, but again, it can be really helpful when it comes to things like debugging. And yeah, okay, this is somewhat tedious, and trying to do that in a classroom with students is probably not going to work, but you will be called upon to do exactly this, because your students, as my students come to me, will come to you with programs that don't work, and they will ask, why is it not working? And unless it's something really obvious, like you have missed a semicolon or something along those lines, you will have to do exactly what you did now. You'll have to say that, okay, well, I can't see immediately what's wrong with it. Let's have a look at an example together, and then kind of manually step through it until you hit that aha moment where you're like, oh, okay, I expected this to happen. What happened was actually this other thing. That's where the bug is coming from. That's where something is going wrong. But again, without doing this, you have a much, much smaller chance of discovering this. So a really, really useful and, in my opinion, underrated skill that is really helpful when you're doing some programming in practice, and useful, if somewhat tedious, to practice this in our activities here. Anyway, I hope that this wasn't too tedious for you, and that in stepping through the game of life and the rules manually, you got a little bit of a better understanding of how this works in practice. Where are cells created? Where do they die? How might I now be able to leverage that knowledge to create more interesting patterns? And then also, if you decide to choose the game of life in the classroom, communicate better to the students what's so interesting about it and how they can make things work better.